Let's go through LeetCode 402. Remove k digits. For this question, it gives us a string num and a integer k. Let us to remove k digits from this num and return the smallest possible. Actually, it should be number after remove k digits from num, right? So this is confusing because integer for this range, this will be, if our length is very big, it will be great out of the bound of the integer. So so we use a string here, right? Even using long, this kind of range will be too big. So let's look at how can we remove those kind of digits will be more efficient. For example, let's go through 1, right? This one, we can keep this, and 4, right? And then we can also keep this one because we can also keep this. And then let's look at the 3, and we'll find for the 3, there is 1 digit on the left, that is 4, right? And also for current that is 3. So we'll see for this number, remove the number on its left which is greater than current current digits, right? That will be more efficient than current digit. So here we remove 4. If we want to remove one number, remove 4 will be more efficient than remove 3. Here we come to the number 2, right? We'll say if we want to remove 2 numbers, then we remove this 3 will be more efficient than remove 2, right? So the thing is that the rule is that if we have a character on its left, if there is greater number, then we remove the greater number on the left will be more efficient than the current number. So that is the first rule, is that left larger, more efficient. Second rule is that we should try to remove those kind of numbers from the left to the right. So for example, you want to have 1, 2, 3, and 9, 6, right? To remove this number, 9, we'll see if 9 is greater than 6, 4 is greater than 3. But which one is more efficient? Is that the higher this one, right? The more on the left will be more efficient. So when we remove that, we try to remove this first. That is the higher digits will be more efficient than the lower one. So we remove if we have those kind of for example, we find on the left there is greater one, we remove from the left to right. So based on this rule, what we're going to do is that we iterate this kind of number character by character, and for each character, if we find there is any greater digits greater than current one, we can remove those on the left until we remove k, right? So there is one of the things is that totally we iterate the whole string from the left. We still have some numbers not being removed. We can have a tricky technique is that we can append, for example, a -1 at the end, so that we can still move those kind of numbers on its left. So we know in this kind of scenario, we move left greater, we can use some monotonic, we can use a stack, right? And in the end, what we left on a stack is kind of increasing trend. So we call it a monotonic stack. And in the end, after we go through one pass, we append minus 1 in the end. We can make sure no matter how big is the k, right? We can still remove the numbers. So let's begin to write code for this. So let's say if this num equals or nums of length, num of length equal to 0, we just return we can try what this result is. For example, this is this, right? What is the working? Okay, you say that size has to be greater than 1. So this kind of corner case actually we don't need to worry about that. So we are going to firstly let's change this one to be cherry. We are going to have stack, right? And let's get n equals array dot length. So what we are going to do is that for int I equals 0. We want to append an -1 at the end. So we'll say I smaller equal to n I plus plus. The thing is that we use a character, right? Using character, so we use a char c equals. So if I equals n, we can how do this? Append a char. For example, we can have 0 -1, right? Otherwise, we just use array. Then we'll say while stack is not empty. And stack dot pick. Because this is greater than 0, and a greater than 0. What we're going to do is that we can pop out this kind of character. And always also need to decrease the k number. Right? So if the k we already changed to 0, we don't need to pop anything anymore, right? So that means, for example, we have 1. If k equals 1, right? So that we just need to remove the 4, 3, 2, 2. Then the other ones we just need to push those kind of in a stack. So we'll have stack push 6. We know we append an actual character at the end, so we should pop it. Or we can do stream builder. Let's pop this one first. Okay. So in this case, what left in the stack will be those kind of things like our result. One of the things that for this kind of scenario, 1, 0, 2, 0, 0, right? We know when we find out 0 here, this 0 will pop up this 1. So it will become 2, 0, 0, 0, 2, 0, 0, right? This one is this. So for our result is that we should trim the 0 on the left if we have string builder. So as we already used the deck, so we can use use a core last, right? Use a string builder. We put new string builder. Let's say wow. Stack is not enough. It's not empty. So we'll say if if we haven't appended anything to this string, and on the left it's 0, so we'll say char C equals stack, but for last, right? So we'll say if this string builder but length equals to 0, means we haven't appended anything to this to our results. And also C equals 0, right? Then we just need to continue. So that means for those kind of zeros on the left, if we didn't find a digit to append to this string, we just ignore that. Otherwise, we just have string builder append C, right? So there is one kind of scenario is that after we go through this kind of string composing, for example, 1, 0, right? 0, 1, okay. So this one we ignore. If we want to remove 1 digit, actually in the end is 0, 1, right? Okay. Yeah, this is okay. Just this example, if that 1, 0, right? So we know we want to remove k digits. Actually, this one being removed, this being removed. In the stack it's empty. So we'll say if this string builder we didn't append anything, if its length is 0, we also return 0. So we need to have string builder data length equals to 0 or not. If it is 0, we need to return 0. Otherwise, we return string builder dot toString. And the time complexity will be O(n), space complexity will also be O(n) for this question, because we use that stack is linear.